let's look at this question. So we need to determine the member force in ED, BD, and BC. So we need to determine ED, BD, and BC. And we have two external loading at joint E, and we have one external loading on joint B. And at support A is a roller support, and at support C is a pin support. So now first of all we need to determine the reaction force for this truss. So at support A we have one reaction force go for the vertical direction, we see is AY. At point C we have two reaction force is CY and CX. Okay, so for these truss structures we can write down three equations of equilibrium. So first of all we can write down the equation of equilibrium in x direction equal to 0. So we assume the right direction is positive. So let's look at this truss. So horizontal there are two forces. One force is 6 kilonewton. So it's 6 kilonewton go to right direction, so it's positive, so 6. And the second force in horizontal direction is Cx. So Cx go to left direction, so it's negative. So we minus Cx, so that's all horizontal force equal to 0. So from this we will have Cx equal to 6 kilonewton. Okay, so the direction is go to right. Cx equal to 6 kilonewton. So second, we can find Ay or Cy. So we need to write down the equation of equilibrium. For example, we write down the bending moment equation of equilibrium at support A, and we assume the bending moment, the positive bending moment is go clockwise, positive. So look at this point A, we have, so for these two 6 kilonewton, they don't have, so for the first one is go to vertically. So these 6 kilonewton have no moment on support A, and the horizontal 6 kilonewton have a bending moment. So 6 kilonewton bending moment times the lever arm is EA times 3. So this is the bending moment because it's go clockwise is positive. So let's look at the 8 kilonewton at support B. So 8 kilonewton have support B and is also go clockwise, so it's positive 8 kilonewton times the lever arm is AB. It's 3. Okay, that's the second moment. And look at CY. CY also have a moment at support A, and because it's go counterclockwise, so it's negative CY. The lever arm is AC. AC is 3 meter plus 3 meter is 6 meter. So for CX, there's no moment at support A, so it's 0. So this is all the moments at support A, then is equal to 0. And from this equation, we can easily calculate the CY is equal to 7 kilonewton. Okay, it's positive. So it's also positive. So it's go to clockwise. This notice. So CY is positive, then it's go up. Okay, so this is CY. So then we can write down the equation of equilibrium in Y direction. If we say the go up is positive, then we check how many force in the vertical direction. We have 6 kilonewton is going downwards, so it's negative. The AY go positive, go up is positive. AY, whereas 8 kilonewton go downwards, so it's negative. And CY is go up positive. CY equal to 0. And we know CY is equal to 7 kilonewton. So we put 7 kilonewton over here. So this is the equation. And from this equation, we can derive the AY is equal to 7 kilonewton as well, and it's go to up positive. So now we have 3 reaction force, Cx equal to 6 kilonewton, Cy equal to 7 kilonewton, and Ay equal to 7 kilonewton. So we have all the reaction force. So once we know all the reaction force, then we can apply either method of joint or method of section to solve the member force in ED, BD, and BC. And look at these 3 member force. So here we apply the method of section. The method of section, we can just cut like this. So we make a cut ED, cut BD, cut BC, and then we will have an. So if we look at the right part of this, after cutting, if we just draw this right part, so let's using the. So we draw the right part. We have a joint D, and this is ED, and we have so BD. We have DC. Okay, so C. So at the point of C, we have 2 reaction force. So it's Cy 7 kilonewton and Cx 6 kilonewton. Okay. Also, we need to know the member force. So now we draw the member force on this part of truss. Okay, we're drawing over here. So we assume the member is in tension. So the member is tension, then the force is go outwards from the joint D. So we have this force is FED. We assume in tension, so go outwards. So if FBD, and this is FBC. Okay, so we need to know the member force in ED, BD, BC. So that's the force FED, FBD, FBC. And we know the FBD, FBC, they across to one point. This point is B. Okay, so now if we just write down, so if we're using method of section. So so if we're using method of section, we write down the bending moment equation of equilibrium at point B. If we choose this bending moment equation of equilibrium, then FBD, FBC have no bending moment at point D. So we don't consider FBD and FBC. And if we assume the positive directions go clockwise and look at FED, we know FED have a bending moment. So FED and the directions go counterclockwise, so it's negative. And times lever arm is BD. So BD is 3 meters. Okay, and now look at the reaction force. So 7 kilonewton go vertical direction, and 7 kilonewton have a bending moment at the point B. 7, the bending moment is counterclockwise, so it's negative 7 kilonewton, and the lever arm is BC. BC have a length of 3 meters. And look at 6 kilonewton. 6 kilonewton is go through the point B, so there is no bending moment, so it's 0. So this is all the bending moment at point B is equal to 0. And based on this equation, we can solve FED equal to negative 7 kilonewton. Okay, so that means the ED is in compression. So after we know the FED, so then we can solve FBC or FBD. So it's quite straightforward. So if we want to solve FBC, we can just write down equation of equilibrium in x direction for this part of truss. So if we say the positive directions go to the right direction, we have FED. The FED is negative FED, and we know FED is minus, so it's minus 7. It's minus 7. Okay, this is FED. And FBC is negative because it goes left direction. and then we have 6 kilonewton is negative as well, equal to 0. So then we have FBC equal to 1 kilonewton, so it's positive, so that means the BD is in tension, 1 kilonewton. Then if we write down the equation of equilibrium in y direction equal to 0, if we say the go up is positive, then we check FBD is go downwards, so speed is negative. And 7 kilonewton at the point C is go upward, so it's positive, equal to 0. And then we can solve FBD equal to 7 kilonewton, and FBD, this is not FB, so this is FBD. So 7 kilonewton, so it's in tension. So this is the answer. FBC 1 kilonewton in tension, FBD 7 kilonewton in tension, and FED is negative, so it's compression. So this is the solution for this question. We're using the method of section to determine the member